Hello everyone. This lecture is a continuation of our previous lecture. In previous lecture, we started the positional measures like quartile, decile and percentiles. In this lecture, we are going to cover the exploratory data analysis or EDA in short and also some associated topics. Let's find out. Exploratory data analysis mainly focus on analyzing the data. To know your data more completely, you need to identify its characteristics. In real life, we have to deal with a lot of data set. Especially in practical life, there's a lots of variation in your data sets. To identify those unknown characteristics, you can take help of the following attributes here. Like first one, we have here distributions. That means how your data is distributed. Is it a symmetric data? Is it a normal or bell-shaped data? Or is it skewed? After that, we have data quality problems. That means, is there any kind of error or roughness in your data set available or not? You can find out that things too. And that can be done by exploratory data analysis. Then the next one is outliers, which is also known as extreme value. If your data has lots of outliers or extreme values, it can affect your data. It may be affect your analysis as well as your conclusion or results, which maybe gives you a wrong interpretation about your data set. The next one is the correlations and interrelationships. This correlation between variables or in a data sets, you can find the linear relationships. For that, you can also use the EDA. The next one is subsets of interest. That means how can you utilize your data to get your required or study variable? Is it possible? That also can be done by using the analysis tools provided from EDA. EDA or visualization can play a vital role to identify the unknown characteristics of your dataset. Let's do a quick recap of our visualization part. So here we have a donut-like things, right? I hope you all know what this graph is called. Yes, you are right. This is a pie chart, and each portion presents a percentage. So that means a pie chart provides us a very healthy information about the different flavors of a donut, and you can get your favorite parts from here whenever you want. Here we have two different diagrams. Both are similar in type but gives us different idea. The first one, or in the left side, we have the death rate per 1,000 people. It is a data set which is decreasing as the year increases. So could you find out the pattern of this data set, or could you identify which type of shape this data set belongs to? Yes, you find it correct. It's a positively or rightly skewed data set. Similarly, in the right side, we have the population data of Bangladesh, started from 2010 up to 2020, which is still estimating the value. So in 2019, the total population was 165.2 million, and you can see a sharp increase. As the year increases, the population value is also increases. So if you try to find out what is the shape of this data from the point of view starting from 2019, and you are going to look back at previous, the shape looks like a negatively skewed, or you can say it's a data set It could be a positive if it's just a mirror part, but the idea is just like looks like it's a negatively or leftly skewed data set if you taking the current year as the starting and going back towards our previous years. So that's how they actually, or the data set looks like. Now the main goal of EDA is to get a general sense of data in terms of means value, medians value, quantiles value, just like quartiles, deciles and percentiles, and using the histogram box plot. Then in short we can say the measure of central tendency, measure of positions, and the visualizations. We always try to look our variable, how we can express our variable, how we can visible to others these variables, how we can show our variables others, or what we are thinking. The way of expressing these variables is exploratory data analysis. Now, humans are the best pattern recognizers. That's obvious. They can identify how the shape's going to, or how the data turns out to be. So this EDA can help us that this data set might be going to be a positively skewed, negatively skewed, symmetric, or any other shapes if it has, with the terms of bigness also. And the next one, we can say that the data maybe have 2 dimensions, or the data have more than 2 dimensions, like 3 dimensions, if the data set has space, color, and time, etc. In usefulness, very early stage of data mining, it helps a lot by detecting outliers. Also, we can test the assumptions of symmetrical or skewness and identify the raw data and transformations by using proper mathematical operation. So the bottom line or the tagline of this EDA is, it's always well worth looking at your data. So when you are looking at your data and how to express, you can take the help from exploratory data analysis. Now we are going to do a quick recap of our skewness measures. The formulas, we have Pearson's coefficient of skewness. We are going to use this formula when we have these 3 values like mean, median, and standard deviation. Then you can use this formula. But when you don't have the median, but you have the mode value, you can use this formula like mean minus mode divided by standard deviation. There's a slight difference, which is 3. So basically, if our mean value is greater than median, then data set is positively skewed. Similarly for this formula. So basically, if our mean value is greater than median and mode, we have said that the formula is based on the mean, median, and mode. If mean is greater than median or mode, we can easily say that data is positively skewed. If median is greater than mean or mode is greater than mean, we can say it's a negatively skewed. As a standard deviation is a positive term, it can't be negative. The formula we didn't discuss previously is this quartiles formula. We already know what this means. Q3 means third quartiles or upper quartiles, Q2 median or second quartiles, Q1 is the lower quartile or the first quartile. And this Q3 minus Q1 terms means IQR or interquartile range. So if the difference between these 2 quartiles, that means the upper quartiles and the median or the second quartiles, is greater than the difference between second quartiles and the first quartile, then we can say it's a positively skewed data. If the difference of second quartile and the first quartile gives us a larger value, then it will be a negatively skewed data, because this IQR can't be negative. Q3 is always be greater than Q1, but we're talking about here the difference between these 3 quartiles. Look at this problem, we have already discussed this one. Now if you're trying to find out the skewness by using 2 formulas. For the first one, Pearson, it gives us a value 0.42, which indicates a positively skewed data, and using the Bowley's coefficient of skewness we get 0.17, which also gives us a positive value, which indicates the data set is a positively skewed. But there's a difference between the value. That doesn't matter. We told it earlier. We are only considering here the sign or the direction. Is it positive or negative? In positional measures chapter or in calculating median, you have to face a term which is order, right? You have to order that data in ascending or descending order whenever the situation, like if you try to find out the median, quartiles, deciles or percentiles, the median like measures, you always have to order the data. But how to order the data and why we need to order the data? It shows the range. If you order a data, you can easily find out the minimum value and the maximum value. It provides signals about variability within the range, may help identify the outliers. If you arrange a data set, you can easily find out if there is outliers or not. Yes, if the data set is too large, then the order may be not that much useful. So here is our raw data, which is unorganized. If you ordered in ascending order, you can get this one. So from where you can easily find out the lowest value and the highest value and the other measures we want to calculate. Now, how to arrange this data a little more smoothly? That's our main concern. Let's find out.